Okay, I'm making the stove video here, and I achieved 987 degrees Fahrenheit in the wood stove, the 2-dog stove. So all the research paid off. It was a complete success, but I had to change the design so that at first I was freezing in the Hermit Hut because the stove was super hot, but I had these dense fire bricks that were absorbing all that heat. So when I took the 2 bricks off that were along the wall near the front door of the stove, then the exhaust temperature in the stovepipe increased by like 200 degrees, and so did the heat going out the front door, since it has to go forward and then up over the baffle like this. And so those bricks were, when I took them out, they were like 400 to 500 degrees, and they're rated up to 2700 degrees. So they just absorb and absorb and absorb heat, and they're still along the bottom of the stove. And then I got the double horn vortex, which is the infamous double the batch box design for a rocket stove mass heater. And I got that because, just like the batch box uses a secondary air channel, I also used one, and then so that would create this turbulence against the baffle, and the batch box also has a kind of a baffle before it goes out the riser. And I also have a kind of riser because I have a stovepipe goes up and then it goes off to the side like in a rocket stove. So here I have a 4-gallon pot of water as the thermal mass, and that's the last thing to cool down after the stove stops. That'll stay hot for a few hours, maybe like 4 hours or 5 hours. And these bricks stay hot not as long, maybe a couple hours or something. So these are the heat exchangers, the strips, and they're aluminum. And then I got some stainless steel chain, and that's mainly wrapped up along the base. And then I got the fan going over here. And this is all the snow on the outside of the Hermit Hut. It was basically buried in snow, the whole thing. And so I had to first, before I do anything, I gotta get the snow off so I could then take off the support beam, the support post in the hut that makes sure the roof doesn't collapse from all the snow. And so I got that off. I had to like pound the snow off because it's hard crusted on there. And here's the secondary pipe right here. This let's see if you can see it better. There, you see that on the left there. See how that's literally the air. As soon as the air comes out of the pipe, it just ignites, and it's actually blue. You can't see it on the camera, but there's like blue light all throughout here. That's why it has that strange color. It's not really a color. It doesn't show up. And so that's it's basically like having a little propane or natural gas flame that's just burning off the gases. And I had absolutely no wood pollution smell at all coming out of the chimney, so it was just awesome. And then when I open the stove doors, then I heat up the hut really fast because it's twice as hot, you know, the stove. And then here's the secondary pipe. If you're looking down along the front door, you can see that 1/2 inch pipe, and I got it set up where it just sucks in the primary air, and then it goes to the back of the stove. And it's a good thing it's stainless steel, because the steel baffle is already oxidizing, so it's going to get burned through, and I'll have to replace it with a ceramic fiber board. And I have extra, so I can do that. And this is the stovepipe that goes off at 30 degrees into this sidewall, which is all cob that I made. Basically just clay and straw and mud and manure, horse manure, and there's some cement in there a bit. And so here I have the boots drying off and the gloves, and that's one really nice thing about a wood stove, because in the winter when your clothes get all wet, then it's really dangerous. And if you don't have a wood stove, then it's hard to create that really good drying heat. I mean, you can put some stuff in the dryer, but you can't put your boots in the dryer, you know, and you can't put wool socks in a dryer really, because they shrink so much. And so I had the wool socks there, and the gloves, and of course, if you don't have access to a dryer, you know, then it's... So this is all the other links I had on there. So I've kind of already did videos on this stuff before, and so this was the design. I took down, I didn't make that aluminum part as big, but I still used it. And it's weird looking through the phone to use the mouse, which is kind of strange. Anyway. So that's pretty much it. I did a lot of research to prepare for this modification, and if I had not done that research, then I wouldn't have been able to stop the problem I had, because I was freezing inside the hut at first, and I had to figure out, these are the pumice. I had one of these in the back. This is an insulation fire brick, so it doesn't absorb heat, but it breaks really easily, but it protects the ceramic fiber board. So I put one of those in the back of the stove. And then I ended up getting the other kind of fire brick it can handle, you know, when you put logs on it, it doesn't crumble. And the fact that it absorbs heat will, that makes sure that you get a full burn out of the wood. And your stove, it will continue, it'll keep heat as it slowly burns down, and it doesn't just cool off really fast and then you get, you know, chunks of wood, since you got that heat absorbed. And so at first the exhaust was too cool, and that's what he has with the Double M Innovation. His exhaust is cooler than the boiling point, so he gets condensation, but he's not worried about it because he has such a clean burn, and he gets up to 1400 degrees. And so that's pretty much how I felt at first. I'm like, well, I'm getting 900 degrees, 980 degrees, so I'm getting such a clean burn that it doesn't matter if the exhaust is that cool, because it was like 200 degrees, you know. But then I thought, well, I better not risk it. So I took those other fire bricks out, and then suddenly the exhaust jumped up like 200 degrees, and so I can get the exhaust up to like 600 degrees easy, 650 degrees once I get the thing going good, going strong. Just load it up with wood, you know, and I got more room for more firewood. And let's see, so I lost the mouse. Well, you can see these other videos. I'll link to the previous videos I already did. So I have more photos of the fire was so hot that I could barely hold up the camera in front of the wood stove for like a minute. If I would just, my hands would just start to burn. Even if I was like a foot or 2 feet, like a foot and a half away from the stove with the door open. And I thought, you know, so I wouldn't really want it any hotter. That's the thing, because I have the bed right by the stove, and so it's still I'm glad it's so hot, because it's so cold up there otherwise. You know, it's like Arctic weather. Like, it was just 35 below zero temperature in around that area. So to get this kind of heat kicking out of a stove it's really necessary to survive, because you really need the heat to spread. And then, you know, I have that eco fan. It does help. You can't really notice it a lot, but it creates a small breeze, you know. And I got lots of photos with the fire and all that kind of like pinkish color. That's actually the blue flame. There was tons and tons of blue flame, which shows that you're burning off the higher temperature wood gas, like the methane, basically. And so it's pretty fun to look at. It's just like, looks like a volcano or something, like lava jumping up. And it's like a lot of fun, actually. And you know, the main concern was the car battery, because it was cold enough for the car battery. The fact that you can actually see the little propane natural gas pipe, you know, it's just that air gets preheated and it just ignites it works perfectly, because the whole point is once you got to get that air hot enough to then ignite the wood gas. And so by having the secondary air pipe under in the coals, then you're making sure it's not the primary air from outside, because the primary air coming in it comes in at like 200 degrees Fahrenheit, but then by the time the reading of that pipe is 980 degrees Fahrenheit. So it's just as hot as the hottest part, and it just ignites it's just like a flickering of the air just immediately ignites. So it worked perfectly. Because actually the Double M Innovations guy, he said he put in a secondary air pipe in his masonry stove that also has the same kind of ceramic fiber board, and he said he didn't notice any difference, but I don't know why. It depends on how much air you're feeding it. And so I found that it did work best to just leave the front open fully, because since I have so much ceramic fiberboard in there, then there's not as much air space in the wood stove, so you want more air coming in. And then he said something about how he could have used more air coming in to burn faster. Like the fire, since it's burning so hot, it needs the air. But on the other hand, you want the secondary air. So if you open up the door all the way, that will actually cool down the fire so that the exhaust temperature goes down, because that exhaust temperature is coming around the baffle back up to get, like, a lot of it is, see how it jumps, so it has to go forward towards the front of the stove, so it's being cooled down, because I took the absorbing bricks down. So the absorbing bricks they're not stealing the temperature from that 980 degrees. So that way the air stays hotter in the front of the stove, and that way when it goes over the baffle to exit, then it is a hotter temperature. Whereas what he does is he has two big dense bricks right where the main air exits his stove in the back. Whereas I don't have much space in the back for the air to exit. I have it pretty much like blocked off in the back. I mean, there's some space, but there's not a lot. So most of the exhaust is coming up to the front, and that's how it's supposed to be in a baffle, because it forces the exhaust back over the fire, and that's why you're getting this double vortex thing, because it slows the exhaust down. Instead of just getting sucked back up the rocket, it's being turned back around into a double horn vortex. And so I'll leave it at that. Thanks.